So here we're going to cover a number of epidemiologic terms: incidence prevalence, relative risk, odds ratio, and attributable risk. So prevalence is the proportion of a population that has a disease or condition at a specific point in time or over a specific time period. Incidence is the number of new cases of a disease or condition that develops in a population at risk over a specific time period. This is a cartoon analogy. So our bathtub is representing prevalence, the amount of water, or basically people with the condition, in the bathtub in the population at a specific point in time. The incidence is the number of new drops of water, which are new cases, adding to the bathtub or population during a specified time period.
All right, now calculating some of these common epidemiologic risk measures. So relative risk, or risk ratio, is the ratio of the probability of an outcome in an exposed group to the probability of an outcome in an unexposed group. It can only be calculated from a cohort study over time. So you need at least 2 time points because, again, incidence, you're measuring the incidence or development of new disease. Commonly demonstrated in a 2x2 table, same as an odds ratio on our next slide. So very commonly set out like this. So the rows, you have your risk factor status, exposed, not exposed, and then your health outcome, diseased, not diseased. It could be mortality. You need to think, however, when you're calculating these, your table actually could be reversed. So think about what it means as opposed to just those calculations. A point estimate of a relative risk, again, is you're looking at the risk of developing an outcome in exposed versus unexposed. So looking at this 2x2 table, it is A over A plus B divided by C over C plus D. So it's the number of diseased in the exposed over divided by the number of diseased in the unexposed, and that's your relative risk. All right, an odds ratio. An odds ratio you'll see very commonly calculated because we calculate that from a case control study, which takes less time and less money to conduct than a prospective cohort study. It's actually a good approximation of a relative risk for rare outcomes, and I'm going to show you why that is. Still usually overestimates just slightly what the true relative risk would be. And you'll see our 2x2 table is set out the same as it was for relative risk on that previous slide. So the health outcome, you're identifying people as a case or a control, again, exposed or unexposed. Again, remember that it's possible that folks will turn the 2x2 the other direction and you would still understand how to calculate it, but typically set out this way. The point estimate for an odds ratio is the number in cell A times D divided by B times C. And the reason that works is for rare outcomes. I'm going to pop back a slide and show you why that is. So the rare outcomes are those cells in A and C. And if you look at the point estimate for the relative risk, it's not really going to affect A and C because they sit by themselves. But in the denominator, the A plus B and the C plus D, the A pretty much goes away if it's a rare disease again. It doesn't have a lot of influence against B. Same with C relative to D. So effectively, it's A over B divided by C over D, which then becomes A times D over B times C. Again, why that works for rare outcomes. The odds ratio is similar to a relative risk. All right, attributable risk or fraction is used a lot in public health. We don't have the money to do everything we want to do, so if we want to try and prioritize our public health dollars for public health messaging, where will we get literally our biggest bang for our buck in terms of the proportion of disease due to a given risk factor that might be modifiable in a population? So attributable risk, you see the definition here, it's a measure of the proportion of disease in disease subjects that's attributed to a particular exposure or risk factor. And an example would be, so our more recent data, the percentage of adults who smoke has been dropping. So aged 18 and over who currently smoke cigarettes, from CDC data in the US, age adjusted in 2018, was 14%. at a high that was much higher than that. It's been steadily decreasing over time with public health messaging. So only 14%. The fraction, however, of lung cancer deaths attributable to smoking is 75%. So you can see then with this high attributable risk for lung cancer that we want to develop campaigns around cigarette smoking. All right, measures of effect size, that incidence, relative risk, odds ratio, and attributable fraction. Pulling that all together from a 2x2 table. So smokers and non-smokers, common thing to target again, associated with so many health outcomes. I've just put serious health outcomes. Could be lung cancer, could be colon cancer, could be heart disease. Many serious health outcomes associated with smoking, obviously. So let's start with incidence. And that's just calculated. You've got assuming that this then is this hypothetical cohort study, you're just looking at how many people have developed that outcome over time. So 518, regardless of exposure status, divided by the total number of the cohort, and 0.50. Our next one is our relative risk. And again, that's a comparison. So looking at 499 divided by 961, so the number of smokers who developed a serious health outcome divided by the total number of smokers, the number of non-smokers who developed a serious health outcome divided by the total number of non-smokers, and that gives us our relative risk of 2.05 and our interpretation, and that's really the important part, right? Not the calculation. Y'all aren't going to need to calculate this. You can just plug this into an app and poof, out comes your number. But understanding what it means is what's important. So here, smokers have, with a relative risk of 2, a twofold increased risk of a serious health outcome in comparison with non-smokers. So next is our odds ratio. And again, we're looking at the AD, A times D divided by B times C, and you get a 3.18. And remember that I said that an odds ratio oftentimes overestimates a relative risk, and you see that here. The reason for that in this case is because the serious health outcomes actually relatively high. So in that case, the odds ratio really is not as good a representation of relative risk.